Alright guys, I got this very nice Hampden Engineering MCB-1 microprocessor trainer like 5 years ago on eBay for $50 or so, and I got it from a retired community college professor, so he was nice enough to actually send me 3 of those. 2 of them didn't work and I sold them for parts, but one of them was in good enough shape and condition to actually get being fixed, so I was able to fix it. But even though I have some documentation for the system, how to program it was actually always a bit of a mystery to me, and this is partly because the manual doesn't go into great detail how the hardware is set up. So there are programming examples, as you can see here, right? But for example, with regard to input and output, it never really explained how you could, for example, put register or memory contents into the display. All it did for output was it was using the output ports and the LEDs. And so a couple of very good examples how to do addition and BCD addition and subtraction, and the results would show in binary on the little output LEDs, right? And then in the end, the programming chapter in this otherwise great manual ends with a quote, okay, freeform, now it's time for you guys to program something. And there are 3 monitor routines in the built-in operating system monitor, which actually can do keyboard input, display, and delay, and those are useful subroutines to be used for your own programming projects, obviously, right? So I figured, yeah, that would be so nice if I actually had the, addresses of these routines and also knew the calling conventions, which registers to use, for example, to display RAM contents on the display, right? But unfortunately, neither the ROM listing nor the schematics were present in this manual, right? So I was kind of, stuck at that point, and this is why I basically almost gave up like 5 years ago. So in the meantime, there was a successor to the system, which was called the MCB-1A. So I have the MCB-1, and so that is a largely improved version. For example, it had 16 kilobytes of RAM, whereas this one only has 4 kilobytes, and so on. And so this manual actually contains the schematics, as you can see, right, for the different sections. So it even has an EEPROM programmer and so on. It has serial and parallel interface on board and a PPIO chip, and in the end, there we have the ROM listing, right? So of course I was then able to basically acquire also from a ROM dump the listing from the EEPROM within my machine here, right, and read that out and put it into a file. And then of course since this is the improved version here in the MCB-1A, for which I have the annotated commented ROM listing, it was pretty obvious that it didn't match very well, right? So all the addresses were of course different, also the programming was a little bit different, but the overall structure of the monitor program between the MCB-1 and the MCB-1A successor, which is the ROM listing here, were sufficiently close so that I could actually then use the annotations and the commands in this MCB-1A ROM listing to figure out and identify the corresponding routines and their addresses and the calling conventions for my MCB-1. So for example, here you will see the keyboard input routine for the MCB-1, and I was able to find almost the exact same program in the MCB-1 ROM, and same for display and so on. So that was of great help. So I simply compared the MCB-1A commented and annotated ROM listing with the MCB-1 ROM dump, and then I was able to figure it out. And yeah, so now I was then able to burn a little EEPROM here, and with a PC, right, and actually have a working demo program now. So this is a highly configurable machine. So this is the OS ROM really. This is a user supplied ROM. It's optional, right? So I simply have a copy of the OS ROM here. And then this is really an EEPROM burner. I wasn't able to use the EEPROM programmer, so maybe there's some defect here. But as a ROM, it works perfectly fine if you put a 2716 in there. So all of those are 2716As, and I burned them on the PC with the Mini Pro TL EEPROM burner. So you can also basically change the address ranges into which these ROMs are mapped into. For example, the OS ROM is from, and I made stickers here, goes from 0 to 07FF, right? So those are 2 kilobyte ROMs, 2716s, right? And then this optional user ROM goes from 0800 to 0FFF, and then the EEPROM goes from 8000 to 87FF. So I put two programs in here. The first one is a counter demo, so we can, yeah, sometimes it needs a reset here. Good. The keyboard is also a little bit, old, and so we start the program at address 8000, and you see what it does. Also here in the breadboard area, basically the three outputs, the three ports from the PPIO peripheral interface chip are available, right? And you can see the display, of course, shows a bunch of crap because it only has characters from 0 to F for the hexadecimal digits, right? And it has a couple other letters as well, but most of it is just from the decoding, just random stuff, of course. So yeah, and the second program I put at 8100, and this demonstrates basically the keyboard input routine, which was actually the hardest part to get working and to understand from the ROM listing. Well, at first it wouldn't work at all, but that's a longer story, and it has to do with the way how the keyboard basically is being read by the CPU, the 8085. So basically whenever a key gets pressed, it generates a restart 6.5, and this generates an interrupt basically for the 8085, and then a restart is being executed, and that restart then basically reads in from the IO bus the key that had been pressed. It debounces it, it decodes it, and so on. So that's a complicated story, and actually also the 8085 interrupt masks play a role here. So at first I wouldn't work at all, and the reason was that I needed to put the 8085 into a certain masked interrupt mode first for the keyboard to be read and processed properly. But yeah, that got sorted out, and it's actually a very nice system, I must say. I'm happy I got it running and that I understand now how to program it. So I'm able to do keyboard input, process the input, display the output, right, and even have a little breadboard area for experiments. Let me just turn off the light so we can see those nice LEDs glowing a little bit better. Let me reset it again and let's start the counter again. And yeah, so enjoy, and until next time, thanks for watching.